Welcome to your 8th Python web scraping tutorial. In this tutorial we have the results of the 7th Python web scraping tutorial, where we went out to Bloomberg.com and we downloaded a JSON file, and then we split the JSON file using the JSON library, and we referenced the associative array using the key data values, and then we just printed out the closing price. So what I'm going to do now is just run this for you, and you can see it printed out the closing price for every minute of the day. And also what I've done is I have added symbols.txt, which is basically just that list of symbols we got from NASDAQ in one of the prior tutorials. So I have that loaded into the Google price directory, the same directory as scrape.py. So what I'm going to do now is I'm going to loop through every symbol in this list, and I'm going to make the same request and see if we can't download the points, download the minutely stock data for every symbol from this URL. So what I'll do is I'll say symbols list equals open symbols.txt .read, because we want to read it, and then I will say symbols list equals symbols list dot split, and then we want to split on the \n character. Yeah, that's correct. So now I want to loop through every symbol, so I'll just say for symbol in symbols list, I want to make this request for every single symbol it finds. And we actually have to split this URL because this is the piece that will change here. So I will, instead of putting Apple, I will put I'll just split this open here, and then I will add symbol. And we want US because we're assuming that all of these are US equity. And I think they should be if they're traded on NASDAQ. So data equals load HTML text, data points, and we basically want to do this for every single symbol. And what we're going to do here is actually nest a for loop. And if you don't know about nesting, for every symbol in the symbols list, it will perform this for loop as well. So it's actually n squared time complexity if you have a nested loop such as this, but it's actually still pretty fast even though it's n squared. What we could do is implement this using threads, which is what I'll do in the next few tutorials, is start using threads. But right now we have a linearly implemented algorithm that has n squared time complexity, which means as symbol increases linearly, this algorithm will increase n squared for the amount of time it takes to execute. And we'll just print out this point after every single symbol. So we'll print the price of or actually we'll just type symbol, comma, symbol, and then we will print time, because if we remember, point in data points is actually a tuple, and the first the first element of the tuple is the time, so we'll put in 0.0 to give us the time, and the second part of the tuple is the price, so we'll say price 0.1, and we'll save this, we'll run it, and it looks to be executing correctly. It's getting the prices. Okay, so we'll kill this, and we'll go back to our symbols list, and it was starting with the V's. I don't know why. Let's see if we can't figure this out. Symbols list equals open dot split. For symbol in symbols list, execute this code. And what was it giving us? vmed the first one it printed out was VIA. So we'll go to symbols list and we will find VIA. Which seems strange to start with that. How about we just do this for the first the last 100 symbols or so. So we'll delete all these, save that file, and then we'll run this. It's still executing for VIA. So actually what I think is I think that this symbols.txt file is incorrect. I don't think that's... Let's open up symbols.txt again. Okay. I just want to know why it's going to VIA. So let's try this just for SPY. SPY, Apple, TVIX, and then we'll run this. Still VIA. That's weird. And you might be wondering, why is this doing this? And the reason is because when you open a file, you have to actually say the directory it's in, because Python 27, python.exe, we actually have another symbols.txt file, which is in the same directory. So we don't want this symbols.txt. We want the symbols.txt in stock program. So what we do is we go to our program and we say Google price / symbols.txt, because your the path that you have to open from is from the exe. So the exe assumes that it is the root directory. So now when we run this, it should execute perfectly. SPY, Apple. Oh, this is working absolutely perfectly. So now we can change our symbols.txt back to the full list. Or we could just do it for these 71 symbols. I'll just start with Apple so that we know it's starting correctly. So we'll save that, save this, P to run, and let's watch it execute. It's executing in a linear implementation. So you might be wondering, it's cool to print it out to the screen, but if I want to run some real analysis on this data, we have to print it to a file, or we have to save it to a file. So next we'll do that. So we have to make a new file in the Google Price directory. So I don't think that we want to save them all to the same file. I think what we should do is make a new directory in the Google Price directory and save all of our text files to it. So we'll make a new folder called daily prices, and that's where we're going to save all of our files to. So for symbol and symbols list, we want to make a new file. So how do we make a new file? We'll say my file equals open Google Price. This has to be in quotes / what was the name of it? Daily prices. Daily prices. / and then our file name will actually make it / symbol, and then we will add .text to the end. So basically what this is an example of is dynamically creating files. And the way that we dynamically create them is symbol changes after every iteration of this loop, so it'll actually change the file name that we're accessing. And then we have to say what we're going to do to this file, and we're going to write to the file, and we're going to create the file. So W+ actually means we're going to create a file. So we can do my file.quotes. So we basically just made a file, and then we closed the file. And then in this lower loop down here, what we actually want to do is we want to open the file and we want to append to the file. We don't want to write to the file every time, because that would just overwrite what we've already put in. So if you were to write to a file and you say write hello, it would write hello to the file. And then if you say write hello again, it would write hello again, and then it would write hello again. But we want it to append to the file, so if there's already hello in the file, it will append it to the end of the file, and it will keep appending to the end, and it won't delete what's already in the file. So we have open the file, and we want to open it to append to it, so we'll say my file equals open, and we want to open the same exact file, except we don't want to create a new one named that same name. We want to append the file. And then our file's already open, so what we can do is, instead of printing this, we will file.write all of this. And I don't think that we actually need the commas don't work because we are not printing to a stream. Printing to the screen. So we'll just have symbol point 0, and the price. And why don't we save it as a CSV? So we actually have to add the commas in here. So here we have the commas added, and when we actually run this, point of 0 is an element of an array. It's not a string. So you can use the string command in Python. And what the string command does is it basically converts whatever data type you executed on to be a string. So we're just going to be writing string to a file. Seems simple enough. And after this for loop executes, what we want to do is close the file. So we'll say myfile.close. Save the file. Let's try running it. Cannot concatenate string and long objects. So string, symbol, point of 0, and point of 1. We actually can't concatenate them because point of 1. Let's try concatenating these separately. So we'll convert each individual one to a string first. Descriptor write requires a file object but received a string. Okay, so it needs a string. So let's try writing just hello to the file after every single the script file.write. It requires a file that received a string. Oh, I found the problem. There's actually nothing wrong with what we're inserting to the file, but instead of file.write, it's myfile.write because the name of our file is myfile. So it was just a typing error there. So we'll save that. It should run perfectly now. Cannot concatenate string and long objects. So actually what we have to do is still convert this to a string. Convert this to a string. Should work. And it looks like it's working right now. So if we actually go into daily prices, we have all these text files. And it's actually not accessing the ones that have already been saved. So if you can see, this directory is just growing. It has quite a few files in here, and you can see this little bar shrinking because it's populating this entire directory with text files. So we'll open up Apple, and it has actually saved saved all of this. Oh, actually, I see one error here. So, well, oh, it looks like it's finished. So, this directory is finished populating, and it's got quite a few files in it. So I'll just delete this. I'll delete the contents of here. Yes. So I've deleted all the files, and the problem is when we write this, it doesn't go to a new line. So string point 0, and we actually have to add the new line character to the end, so it doesn't, so it skips a line after every record. So we'll add \n, save that, and then we'll run it, Alt-P, and then we can see if it worked. So it's populating our directory with files. Looks good. And they're all named the symbol and then .text. So it's dynamically creating these files. And, oh, that looks good. So it's a CSV file. The first part of the CSV is the symbol, and then there's the timestamp, and then there's the price. So we can actually open one of these with Excel. So I'll open in Excel, and I can do data, text to columns, delimited on comma separated file. So next, finish, and here I have the data that I've downloaded, and I can say insert a line chart, and this is the chart that I get from the data that I've collected. So that just shows that you can use Excel to open these files and manipulate your results. This has been your 8th web scraping tutorial, and in this tutorial we downloaded data dynamically based on our symbols list, and then we wrote our data to files that are dynamically created in a directory of our project. So here's our scrape.py, which generates all of these files that we can open separately and manipulate however we want. So thank you for watching your 8th web scraping tutorial.